Hi, now in this video we are going to deduce the Avogadro's law using kinetic pressure. Now we need to first understand Avogadro's law. Avogadro's law. Now for Avogadro's law, so from Avogadro's law, equal volumes of gases equal volumes of gases at the same conditions of temperature and pressure have equal molecules or moles. We have equal molecules, or we can say moles. So this is the Avogadro's law. So volume is directly proportional to the number of moles. So if the volumes are the same, that means even the number of moles are going to be the same. So we are going to use the kinetic pressure to deduce the Avogadro's law. In other words, for a particular gas, if we have gas 1 and gas 2, if this is P1 and this is P2, you have V1 and this is V2, you have T1 and this is T2. So if P1 is equal to P2 is equal to P, that is a constant, and V1 is equal to V2, and also T1 is constant, meaning T1 is equal to T2 is equal to T, then this implies that the number of moles or the number of molecules N1 will be equal to N2. So our target is to deduce this expression when we have the same volume of gases, then maintaining the pressure and temperature constant. So let us start from the kinetic pressure. Kinetic pressure is given by a third times the number of molecules times the mass divided by the volume times speed squared, and this is the mean speed. So we are going to consider two gases. So that means that P1 V1 is going to be equal to a third Nm C squared if I bring V this side, and P2 V2 will be equal to a third, this is N1 M1 and C1. So this is going to be N2 M2 C2 squared, mean speed. Alright, so now here, if P1 is equal to P2, that is the same pressure, we are going to have the same pressure, and V1 is equal to V2, that means that these two equations can be equated. So we are going to equate the equations. So we shall have a third N1 M1 C1 squared equal to a third N2 M2 C2 squared. Okay, now we have seen pressure the same, volume is the same, and temperature is going to be the same. So we need to create the expression for temperature here. So we can get that one from kinetic energy. We can first introduce the kinetic energy expression here. So this will be, I'm going to multiply with the 2 and divide by 2. So this is going to be 2 over 3. Then n1 times a half m1c1 squared. I am going to do the same on the right hand side, multiplying with the 2 like here, and I divide by 2. So we shall get 2 over 3 n2, then I divide by 2 m2c2 squared. So you can see that now this is the kinetic energy, and that kinetic energy is directly proportional to the temperature. So a half mc squared is directly proportional to the temperature. So we can now easily substitute. This will be T1 and this is going to be T2, but the temperatures are the same. T1 is equal to T2, and we can call it a T. Okay, so we shall be having 2 over 3 n1. Now this one is 3 over 2 kb, the constant, then times temperature, equaling to 3 over 2. It is 2 over 3, sorry, 2 over 3 times n2. Then this one is going to be 3 by 2, bottom one is constant, times the temperature. It will be T2 and this will be T1, but since the temperature is the same, we just write T. And now you can see that this 3 over 2 times this cancels, the same on the other side. So we have kBT cancelling kBT. So it is only n1 remaining, and the other side you have n2. So this is the Avogadro's law. Avogadro's law. The number of moles for gas 1 is equal to the number of moles for gas 2. That is if the volume is the same and you have maintained pressure and the volume constant. We deduce Avogadro's law. Hope this video is helpful. It will help you to understand more questions, especially in calculations, and maybe pass your exams.